Actually, what has been really fantastic for me is the opportunity of meeting extraordinary people. And very often this happens randomly, which means that in order to make this really go to the next step, you have to be open to opportunities. And even if the opportunities come totally unexpectedly. And maybe I can, if you want me, I can give a few examples. The first one, so I was a student at École Polytechnique, and at that time, unfortunately, which should not have been the case, some of the teachers at École Polytechnique were not really of good quality. I mean, they were very well-known people, but not teaching appropriately. And we were in the spirit just before 1968, so the students were unhappy. And we just decided, for example, to organize our own substitute courses. So we trained a team. So the school is, you know, at that time was 300 students at graduate level. And so about 10 or 15, 20 of us organized substitute courses. Anyway, so, but this led me to study very in-depth mechanics, just to be able to replace a teacher, which at that time I was just 19 years old, so it was special. But then it also convinced me later on that probably I was not good enough to do mathematics. And so I decided to try and do mechanics because I had been reading all possible books on mechanics. I had published a small paper and so on. And, but then at that time, the mechanics, well-known people in Paris were very conservative. And so I came to them saying, I have an idea for a PhD, I want to work with you. He said, no, but that's not the way it works. We will tell you what to do. And I went away. So, and then I went away to the field which was the closest to mechanics, which was differential geometry. And then I had the extraordinarily good fortune to meet Marcel Berger, who became my advisor later on, and who has been of incredible generosity with me. And, but you see, it was a random coincidence. He was just offering a course on the topic which was close to what I thought I could be studying. And then not only that, he did two things. First, the first very fundamental thing was that he gave me, well, his seminar was on the Wednesday, and on the Tuesday he dedicated the whole day to talk to me on everything he knew about geometry, which is an incredible, I mean, generous gift to me. And so I learned a huge amount with him, of course discussing. I mean, it was really not just listening, it was really an exchange. So that was the first one. Second one, he was a very, very modest person, claiming that he had not done anything significant in his life, which was completely wrong. But then he had an incredible trust relation with the best mathematician in the world. And he introduced me to Atiyah, Singer, Calabi, and so on and so forth. Okay, so I could talk to these people because I was a student of Marcel Berger. They immediately opened doors and they were willing to talk to me, churn, and unbelievable. So these are, you see, opportunities which, of course, I took advantage of because, but it was not my plan. It was just his way of behaving and being very nice to his students. And the next one, and I will finish my opportunities, was 1972. So I was at that time in France. At that time there was no PhD system, but still I had published some papers and so on. I gave a seminar in June in Paris, 72, and Jim Simons, you probably heard about him, came to Paris, listened to my lecture, and next morning I had on my desk a fax offering me a position in Stony Brook to take on the 1st of September. With my wife, we already had a daughter, and my wife had a job. What do we do? It was the 15th of June. And we decided, let's take it, let's just try it. So we went. And one thing that Jim had been doing at that time was collecting in Stony Brook all the young, promising differential geometers. So Xingtung Yao was there, Chiger was there. I mean, it was 13 differential geometers. So the seminar was like a mecca of differential geometry. So it was an incredible experience for me. Of course, I disappointed Jim Simons because I refused to stay at the end, because with my wife we felt we didn't feel comfortable living in the US, so we decided to come back. But you see, this was, I mean, a random coincidence. I didn't know Jim Simons. I'm sure Berger said a few words about me to Jim. Probably, I have no proof of that, but that's likely. And then we had to decide very quickly, let's do it. And of course, it changed my life and also my wife's life. So you see, this is one thing I learned. And this has been going on like this a number of times, where things which were not expected happen, and then you take the opportunity, and maybe it's going to fail. You don't know. But then, and the last one was becoming president of ERC, which I didn't expect at all. I was pushed to submit my CV, because at that time you were not candidate, you had to submit your CV. I had a plan for the whole year. I didn't want to, it was not my plan. I was supposed to do something else, but I submitted my CV, and then I was chosen as president. But so many people believe I was struggling to get the job. Not at all. It was not like this at all, but it has been a fantastic experience. So this is something I tell young people. I mean, when you see opportunities, just take them. I'm very cautious with that, because you see, the situation for young people now is very different from the situation I had. I was hired by CNRS, I was 21. I had one paper, as I mentioned, which was not really a very extraordinary paper, but of course, as a student, having a paper published is not too bad, but it's not extraordinary. And so today it's much more difficult. So people have to struggle much more. Usually they have to wait much longer, and so on. And one of the big difference it makes to that you have a job, even the job was not well paid, that's not the matter, but you have some security. And the consequence of that is that you can really take risk. You can really look at hard problems, because you know you're not going to be fired next year, even if you don't publish now, not publish quickly. But for people now, it's quite different. I mean, they have to prove themselves again and again, a number of times. And of course, I'm afraid it may prevent them from looking at hard questions. And I don't think that's good. So for the research altogether, but for the people themselves. So that's why I'm cautious when I give advice, because in a sense, for me, it was the ideal situation where when I left École Polytechnique, actually I had 3 offers of a job. And so I could choose from them, so I chose CNRS. I've been employed by CNRS 44 years, which is probably one of the longest employment by anybody in CNRS, because I was hired so young. But still, I still feel that what I said about taking opportunities, and when an opportunity comes, you should take it, is still valid. Even if the environment is much not as nice as the one I could enjoy, which I think is not only a pity, but I think overall for research it's not good. To keep people waiting for so long, I don't think it's the right thing to do. But anyway, that's what's happening. The second thing, which of course has changed quite a bit, and actually I benefited from it implicitly. At that time, when I started, if you were a mathematician, you were a mathematician. If you were a physicist, you were a physicist. If you were a biologist, you were a biologist. These things have changed. It's very important that people have an idea of what other people are doing, just to make it possible for you to move to an area which will be a mixture of things. At my time, it was not the case, but because of the training I got at École Polytechnique, for example, I learned quantum physics quite seriously. I was a mathematician, I was interested in math and mechanics, as I mentioned, but I learned quantum physics quite seriously. And later on, which was just because it was interesting and the teacher was a good teacher and so on, but later on in my own activity as a mathematician, it just happened that the interface with theoretical physics, in particular quantum physics, became quite significant. And then I had an advantage over my fellow mathematicians, because I think I could read a physics paper, I could talk to theoretical physicists, which was not the case of course that's changed completely now. But then it was really the two worlds were completely separate. So again, randomly, because I followed a training which was open enough, that was easy for me. I mean, it didn't mean I didn't have to work more and so on, but still, I had the background which was needed for me to make the move. So today, for sure, interdisciplinarity is extremely important. Of course, you can still do fantastic mathematics in mathematics, period. But still, there are so many fantastic opportunities at this boundary. First of all, nobody knows exactly what the future of mathematics is. Even some people predict that it's going to die because of artificial intelligence. It's not my belief. It's not my belief at all. But nevertheless, I'm sure it will change some things in mathematics. Already one thing which has changed the practice of mathematics, and I'm taking advantage of it every day, is the fact that you have so many resources which are available on the internet. So you want to access an article, you just basically almost surely find it in one way or another. Before, if you were not in the right place with the right library, you can forget it. Or you have to wait for the reply for somebody who maybe will not reply to your request and so on. Now this is just at the tip of your fingers, so it's very different. No, I think the interdisciplinarity is going to be there for sure. And the new feature is, of course, the development of computer science is not just as a tool and enabling to do things we couldn't do before, but even conceptually, the role of discrete structures compared to continuous structures has grown considerably. The role of statistics, or more generally anything which has to do with probability theory and so on, has grown considerably. And therefore, in a sense, to be trained as a mathematician today, of course you can still be in your niche, but it's very important that you are aware that there are all these other possible connections. Maybe you're not going to follow them, but so I think, and you see, I'm even talking about internal interdisciplinarity within the mathematical field. And when I was a student, statistics was miles away. I mean, no idea. Of course, I got closer to one of my sons. He's a statistician, so of course I'm under influence now. But it's clear that statistics and stochastic processes altogether are playing a much more important role than they used to be, partly because fantastic progress have been made, and also because now with the machines we have, with the networks we have, they play absolutely critical role. So you cannot ignore them, even if you can do your own mathematics in your corner, which still will exist. It's very important that people make sure that these possibilities still exist. But overall, I think for somebody who starts now, I think it's very important to have an eye, to listen to other things, and finally to decide to do what you want to do, which should be your decision. It should not be somebody telling you you should do that. That I hate. Actually, anytime somebody is trying to force me to do something, I don't do it. That's part of my personal identity in a sense. I mean, I hate to be pushed. So that's.
Me too.
Maybe that's a luxury. One thing I did very early was to talk to people who were making movies. So in my life, I made several movies, and some very small ones and some more substantial ones. Very often this came either at my request, that is working with, I developed very good personal relation with both movie makers, and I mean, I don't know how one call them in English, I mean réalisateurs in French, people who really make the movies, and also photographers. I mean, I had also some very good relation with quite exceptional photographers, which has been really, I really enjoyed that very much. And again, that was why was it like this? Partly because I felt, as a mathematician, I had to communicate with others, in particularly non-mathematical, audiences, but also because actually I appreciated having this interface with people whose profession is a different one, and so I really cherish actually these exchanges, these relations, and which continue to this day. I mean, I'm still talk to them regularly, and so 3 or 4 or 5 of them really, and not only in France. I mean, some of them are Japanese one in particular. I don't know whether you know Hiroshi Sugimoto is one of the most famous photographers. Very interesting person, very interesting person. So I visited his atelier in New York, in Tokyo, and also made interviews of him, and which was very interesting. That's a very good question. Actually, I'm a Frenchman, so in a country which pretends to be a big one. I insist on the pretend. But of course, it has a real tradition of high quality mathematicians. But you have to be very careful with that, because I think if I look at, as you know, I've been involved in at European level in some ways. I was second president of the European Mathematical Society, but before that, of course, I had also participated in European networks and so on. And then recently with the European Research Council, of course, I was fully embedded into the system. And you know, the countries which really made Europe having a strategy for research were the small countries. When I say small, I don't mean in terms of quality, I mean small in terms of size. And the countries which usually objected to developing this were the big countries. Germany, France, not so much. France was more open. UK, very much. And actually for the UK it's very interesting, because a man who made a big change for the existence of ERC is Lord Sainsbury, from the, you know, the Sainsbury stores. And because at some point, actually a meeting which took place in Dublin, 2004, which was during the Irish presidency, there was a meeting to decide whether the European Research Council should exist or not. So there was a big engagement by Sweden, Denmark, Netherlands, Ireland to get ERC to exist. But Germany was against, France was not interested, and the speech which was prepared for Lord Sainsbury for this meeting was to say UK was not interested. And reading this, this draft of the speech, he said, why should I say that? And he said the opposite. And of course, poof, it made the thing change, because if you have one of the big countries, one neutral, the other one against, but UK favor, and all the big the smaller countries were fighting, and one country which has actually played, because of an exceptional person, a key role was Portugal. Because the Minister of Science in Portugal has been Mariano Gago for a number of times, after the revolution, of course. And he was a particle physicist, and he managed to convince the government to give money to really develop science at a very significant level. But he made a condition that all the evaluation in Portugal should be made internationally, not nationally. Which of course was not well received by scientists, because they felt an intrusion, and the country was totally closed. I mean, the Salazar regime was completely closed system. But he succeeded, and then he has been really the architect of everything we call the Lisbon strategy, was Mariano Gago. And in a sense, what has been really the compass for research policy in Europe has been more or less the inheritance from Mariano Gago. Unfortunately, he passed away now quite some time ago, and but he was an extraordinary man with a vision for Europe, and with a remarkable impact on his own country, but also on all the other countries, in particular the smaller ones, because in a sense for them it's more important than for others not to be closed on yourself. In the case of Portugal, it was extreme, because that was the whole ideology of the Salazar regime, that everything should be closed. So I think for smaller countries, I think these connections are very important. Of course, because of the size, you are not going to be universal. You're not going to cover all parts of a field. But at some point you should identify what are the domains in which you really have good opportunities, good people, in science what makes difference are people. That's well known. That's why celebrating Hamilton is completely appropriate, because they are people who made difference. Of course, after that there is a whole group, communities which organize themselves, which really make the thing happen finally. But at the beginning, there are always somebody who comes with a quite new thing, sometimes rejected proposals. In the case of Hamilton, he struggled to get quaternions for 10, 12, 15 years. But finally, he made it. And really, it was a fantastic contribution to science altogether, not just to his own science. And as you know, the contribution to other fields have been very significant. Of course, he didn't thought about that. It was not in his mind. But that's the way science develops. That is, you create new tools to think, and then you have no idea where it's going to be used. Well, it's a complicated story. I see times are difficult at the moment for many reasons. One thing which is for me during my term as president of ERC was always there. Most politicians, for reasons which you want us to accept, are really obsessed by the short term. So to keep them to admit that one must think about the long term is always difficult. There are very few exceptions, very, very few exceptions. The only country which is thinking long term is China, basically. Maybe some other Asian countries, but mostly China. And you see, probably part of the reason why it is so is because if you look at what is the basic training of the people who are the leading people in the Communist Party, they are, I think, if you look at from one, they are ordered by 1 and so on to 15. I think 10 of them are engineers. Then there is 1 physicist, 1 mathematician, 1 lawyer, and 1 biologist, I think. That's the training the people got. If you look at Western politicians, do you see an engineer? No. Do you see a scientist? No. I have nothing against lawyers or other people. But culturally, people have a different approach. I think just that the attitude of people altogether is a different one. And also China is patient, although the transformation of the country has been extraordinary. My first visit to China was 1981, in a different world. You cannot imagine. I mean, when I landed in Shanghai, there was no terminal. So all the luggage was put next to the plane, and you had to take it there. Well, I don't know whether you have been to Shanghai and so on, but it's just a different world. So this is one thing which is, I think, very important, to get people to accept that thinking long term is very important. And this is true also for large or small countries, it's the same. That's why when you see America at the moment think so much short term, it's a killer for the country itself, not just for the world, of course, but for the country itself. So that's one main difficulty. For mathematics, properly, there is the difficulty that very few people feel comfortable, people meaning people in power, feel comfortable with mathematics. Most of the time by lack of experience or lack of fundamental knowledge, but very often also because, and this is happening a lot in France, I don't know for Ireland, because people claim even they are proud of not understanding mathematics, which for me, I cannot understand that. Well, when I was a youngster, I was really interested in literature and philosophy. And therefore, I didn't think I would become a mathematician. It was not my main interest. I mean, I didn't find mathematics exciting enough. It came later. And so I think this idea that if you are interested in, I would say, humanities or social sciences, then mathematics is irrelevant. It's just wrong. But in the same way, for a mathematician to think that humanities and social sciences is irrelevant is as wrong as the other one. But in a sense, and probably mathematicians have also their responsibility in that, because sometimes mathematicians tend to be arrogant or I mean, not making enough effort to really explain that math is not dead. There are new things happening every day and very significant things. And there have been some turning points in history and so on, and they really changed a lot of things, and a number of things have been made possible because of mathematics, usually never alone, but as some kind of a background which was needed to do some things. And so I think we must keep this idea very much in mind. Of course, with the new developments which are happening so quickly, with all things which artificial intelligence and so on, we have to really be with our eyes open to see what it's really changing. Some things are probably a bit superficial, but probably some things are not superficial at all. And therefore we must really accept maybe our practice of our profession is going to change. Although I have my doubts, but because I really feel that people are so important that replacing people by machines doesn't look to me as some part of it will happen, but certainly not at the extent some people are dreaming.